Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at transformations and congruence. So transformations are just translations, reflections, and rotations. Let's start here. So a translation is colloquially called a slide, though its proper name is a translation. When you translate a shape, you do just slide it, you just move the shape. You need a translation vector. The vector has two numbers. The first number tells you how far you go left or right. The second number tells you how far you go up or down. So what this writing means is if the first number is negative, less than 0, you go left. If the first number is positive, you go right. Similarly for here, if the first number is positive, you go up, and negative, you go down. So if I want to translate this shape using this vector, I need to move it 4 units to the right and 3 units down. So when you're performing a transformation, be it translation, reflection, or rotation, operate on the vertices or the corners. To translate this shape here, I'm going to move or translate each of its vertices. So for A, I'm going to move it 4 to the right and 3 down. So A will go there. So I call this vertex A dash, that means the image of A, that just tells me that A has moved here. So for B, I'm going to move it 4 units to the right and then 3 units down. So B will go there. Similarly, C will move 4 units to the right and 3 units down. So C will go there. I call it C dash to indicate that C's moved there. So when we have all the vertices moved, all we're going to do is just join them up. So this blue triangle is just a translation of the red triangle using this vector. Let's now look at rotations. So for rotations, you need a fixed point and an angle and a direction. So you'll be asked to rotate a shape, say 90 degrees, and be told whether you go anti-clockwise, which is this way, or clockwise, which is that way. So the way you rotate a shape is for each vertex, draw a line to the fixed point, draw another line of the same length using the direction and the angle given. What does that mean? Well, let's have an example. What I'm going to do is I'm going to take this shape here and I'm going to rotate it 90 degrees clockwise about this point here. This blue point will be my fixed point. So this point won't move when I rotate. So let's do this for each vertex. Let's just start at A. So what I do is I draw a line from A to the fixed point. So then what I do is I draw another line that's the same length, but I need it to be 90 degrees clockwise to this fixed point. So I'm going to draw another line that's at 90 degrees. If I went that way, that would be anti-clockwise. And if I go this way, it would be clockwise. So here I've drawn a line at 90 degrees clockwise. These two lines need to be the same length. So point A is going to move here. So again, I call it A dash, the image of A, to indicate that A's gone there. So we're going to do the same for all of them. So from B to C, it's really easy. We have a line already drawn here. So at 90 degrees clockwise, I want to go this way. I'm just going to draw a line that's the same length at 90 degrees. So B would go there. Now C is the fixed point. This is the center of rotation, so it actually won't move. C will actually stay there. And then we do the same for all the others. So for D, there's already a line drawn. D will actually go up here. For E, I draw a line to the fixed point, and then I go at 90 degrees clockwise. E would be up there. And similarly, F would move to here. So once I have all the vertices in place, all I need to do is join up the shape. So here, this blue shape is a rotation 90 degrees clockwise of the red shape. Let's now look at reflections. So reflections are colloquially called flip, but their proper name is reflection. You reflect a shape about a mirror line. So what I'm going to do is I'm going to reflect this shape about this mirror line. So once again, to reflect a shape, what I'm going to do is reflect each of its vertices by following these instructions. So to reflect A about this mirror line here, I'm going to draw a line from A to the mirror line that's at 90 degrees, and I'm going to draw a line in the opposite direction, also at 90 degrees, that's the same length. So notice that this length here, 1 unit, this length here, 1 unit, are the same. So A is actually going to move here, so once again I call it A dash to indicate A has moved there. So for B, if I draw a line to the mirror line, that's 2 units. I need to go 2 units in the other direction, B will move there. Similarly, C will move over here. Now when I come to D, D is already on the mirror line. Points on the mirror line don't move. D is actually going to stay there. So when I have all the vertices, I'm just going to join them up just as they were joined up here. I'm going to join, say, B to C, and C to D, D to A, and A to B. So this blue shape is just a reflection of the red shape about this line here. So now let's look at the opposite, when a transformation has occurred and we need to identify which one. So identifying a transformation can actually be difficult, and we usually need the vertices to tell us which one has occurred. So let's say I have this triangle here and I've transformed it into this triangle over here. Now we can't actually tell which has occurred. It could be a translation or a reflection. We need the vertices to tell us. So if this shape was translated, the vertices would also be translated. When you translate a shape, it stays in the same orientation. So these blue vertices would be if a translation occurred. If, on the other hand, a reflection occurred, the vertices would be reflected. I could take this shape and reflect it about a mirror line here to get this shape here. So if it was reflected, it would still be A up here, but B would be reflected over here, and C would be reflected over here. So the vertices in black are how they would appear if the shape was reflected. So what about to get from this shape to this shape? Well, I know that I couldn't translate this shape to get this shape because the orientation has changed. The triangle, if you like, is facing a different way. So I can't have performed a translation from here to here, but to go from here to here, I could have reflected or rotated the shape. Once again, we're going to need the vertices to tell us which one occurred. So if I reflected this shape up here, the vertices would be reflected and my mirror line would be in here. So I would have B reflected to here, A to here, and C to here. So I could also take this shape and rotate it 180 degrees about some fixed point here. If I did that, C would end up over here, B would end up over here, and A would end up there. So when you're determining which transformation has occurred, if it's not obvious which has occurred, look at the vertices and see whether they have been translated, reflected, or rotated. All right, let's now look at congruence. So the idea behind these transformations is that if you translate, reflect, or rotate a shape, you get another shape that's congruent. Congruent shapes are basically the same shape. They have the same everything, same side length, same angle, same area, whatever it might be. Let's look at an example. So here I've taken this shape and rotated it to form this shape here. So these two shapes are congruent. They'll have the same side length, same angles, same everything. So what we need to do with congruent figures is identify corresponding angles and sides. So this can be a bit ambiguous. We talked about corresponding angles in a previous lesson. They were the F shape and the parallel lines. But here when we use corresponding in the context of congruence, we mean matching. So if I look at these two shapes, it turns out that the longest side here is AB, 5 centimeters. So that means that the longest side on the congruent shape will also be 5 centimeters. These two sides are corresponding because they're the longest side in each shape. Similarly, this is like the second longest side in the shape. So X and 4 centimeters correspond to each other, so they must be equal. Corresponding sides in congruent figures are always equal. So the shortest side, 2 centimeters from A to C, so E to F will be 2 centimeters, and so on. What about Z? Well, Z is the angle between the two longer sides, 5 centimeters and 4 centimeters. So its corresponding angle here is the angle between the two longest sides. So here, Z would be 40 degrees. Because these two shapes are congruent, that means pairs of corresponding angles will be equal. So this angle here would be 18 degrees, for example, and pairs of corresponding sides will be equal. So the last thing we need to be able to do is write a congruence statement. So what you do is you name the first shape according to its vertices, A, B, C, and D. It doesn't matter the order in which you write the first set of vertices. So A, B, C, D refers to this shape here. This symbol here, an equal sign with another line, means congruent to. Now, when we're writing the second shape, we need to match up the vertices. So A corresponds to E. A is like the vertex with the smallest angle, so it corresponds to the vertex with the smallest angle. So because I wrote A first in the first shape, I need to write E first in the second shape. So B corresponds to H. This was the vertex between the two longest sides. So because I wrote B second, I need to write H second because H corresponds to B. Similarly, C, the vertex where we have this reflex angle, well, it corresponds to F. So because I wrote C third, I need to write F third. And of course, that means that D corresponds to G. It's important that we get the vertices in the right order. First vertex need to be corresponding vertices, these two vertices correspond, and so on. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.